Hello guys, welcome back to the channel for another Azure and Databricks video. Today's video would be something very practical. When you host a web application on Azure or when you have an Azure function, then those things are running on an app service plan. An app service plan defines a set of compute resources so that those things, a web application or an Azure function, can run. In our example, we have an app service plan that hosts a web application. And what we are going to do here is gather the metrics like CPU percentage or disk utilization using Azure REST API and Python in Databricks. And then we are going to save this data on the bronze layer and on the serial layer according to the medallion architecture. So essentially it would be a very simple data pipeline based on the knowledge that we have learned on the previous videos. So let's get down to the nitty-gritty. Okay guys, here on the Azure portal I have a web application. If you click on the overview blade and then scroll down, you will see hosting, which means that this web application is being hosted on this app service plan, which is called Apple Web App Demo. So if we go into the app service plan, you will see on the overview blade, if you click the overview blade here as well, you will see here we have CPU percentage, memory percentage, data in, data out. So let's say that we want some metrics like the CPU percentage and the memory percentage, and in our ETL, in our data pipeline, because the client wants a report with all those metrics. So what we can do here to gather this data, to fetch this data from an app service plan in Databricks, is use the Azure REST API and Python to hit the API and provide the app service plan. Of course, you use a service principal that has access to the Azure service plan. So if you go into access control, you have to create a service principal, then add role assignment, scroll down, and you will have to provide the reader role to the service principal so that you are able to read. So here where it says log analytics reader, or reader as well would do. So, and then you provide this role to the service principal that you are going to use to access this app service plan. I have already done that. I'm using a service principal that has access here. So if you go into role assignments, let me show you my service principal. Give it a second. So here, if you scroll down, monitoring reader, actually we want the monitoring reader, so to be able to gather the metrics. Now, if we go to the Databricks environment, the first thing we need to do actually is create a function to hit the API, create a notebook to hit the API. Now, here is the metric URL, which is the management.azure.com subscriptions. This is the subscription ID. Then we have resource groups, the resource group here, providers / Microsoft Web / server farms, and then your app service plan name, and then providers Microsoft Insights metrics / metrics. And then for the access token, first we need a token for authorization. Of course, we need to use your service principal here. So the access token URL is login.microsoftonline.com, and then here your tenant ID and auth token. And then we have content type, application here, and then for access token data, grant type, client credentials, client ID, which is the client ID of your service principal, client secret, the secret of the service principal, resource management.core.windows.net, and then we perform a post request using this access token URL, the headers, and the data, right? Access token data here with the grant type, client ID, client secret, and resource. and then we are going to get back the access token. You can get the access token using response.json and then access token inside the parentheses. Then we have the metric params, which is the metric names, the metric that we want to get the data from, the API version, and then the time span. You can provide, let's say, the last 5 days, the metric headers, authorization, the bearer, and then the access token, and you perform a GET request with metric URL, which is the one that we have here, and then the params and the headers. And then here it would be the JSON that we are going to get back our results. What we can do later on is to use pandas, to use JSON normalize because it's a nested JSON. Use your your response.json and then record path, value, time series, and data. You will see the JSON here. We are going to print it, so you will see the structure of the response. And here we get the values that we want. In our example, you can of course get different columns, the columns that you need. For our example, I just needed the value, .name, and the metric. We filter, and then we create a PySpark data frame from a pandas data frame. And then here we store the data on the bronze layer. Actually, before I get to the bronze layer, let's comment out this part that we save the data on the bronze layer and see actually the JSON that this response returns from the Azure REST API. Now let's run this code. Actually, let's run this code here. Metric, actually, yeah, I have these widgets here where it says the metric that we want actually to get data from, which is CPU percentage, memory percentage, disk queue length, bytes received, bytes sent, etc., etc. The metric name, the metric column, sometimes it's average, sometimes it's total. So I have all those widgets here. Let me run this. And here there's in this drop down all those options. I will tell you why I'm using widgets, but for now let's see what the API response is. Let's run it and see, here is the response of the API. We have the timestamp and the average for the CPU percentage, right? So here is the whole response. We have cost, time span, interval, value, ID, name, type, localized value, CPU percentage, display description, unit, percent, time series, etc., etc., and the data. Here the average is 0, but if you scroll down, then the average is more than 0. It's 1, 2, 3, etc., etc. So this is the response from the REST API that we get. And this is how we can fetch the data from the app service using the REST API. Now, the next thing we need to do is actually process this data and save the data on the bronze layer. I'm going to use, remember in our previous video, in our previous tutorial, we said things about the historical load delta tables. Yeah, the historical loads in delta tables. And here we created a class merge. So check my previous video about it, and we have the class changes. So the class merge is actually to merge the data to the target table, and the class changes detect the changes from the last time, so we can perform historical loads when necessary. Now in this case, we actually just merged the data to the bronze layer. I have used all those parameters, metric column, upper metric column, then the prefix, because I wanted to make it more dynamic, and based on the values that you pass on the widgets, then you can run multiple notebooks at the same time for different metrics, and I will show you that later on. But now, as you can see, we use the Spark data frame here. After we performed all those transformations, take a look because I cannot analyze everything. And then we add the timestamp column here. We create a date key based on the timestamp and a row ID, which is a hash between all the columns here. And we select the columns that we want, and we provide the structure of the bronze schema, and we save the data on the bronze schema. Now, so we have the data on the bronze layer. The next step is actually cleanse the data and perform, let's say, we dedupe the data, add the flags or whatever on the silver layer and build our data model. Now we don't have a data model here. It's very simple, pretty straightforward data. So here on the transform notebook, I provide some input, the input table, the log directory table. So on this path here, we are going to have the delta logs, so we know which version of the data has been moved from the bronze layer to the silver layer. So if we want to perform a historical load between the bronze layer and the silver layer, we just delete the version of the data in the log directory. Then the partition key here, we have the primary key, the output partition key, and the target table. And also we provide again the schema for the silver table. Again, go back to my on my GitHub account, you will see this Python file, and check my latest video about historical loads in delta tables, so you will understand where all this code is coming from. And the next step is actually check which data keys have been added or have been changed, and then merge the data to the silver layer. Just add the flag, for example, or perform not null checks and these kind of things. Nothing very complicated, of course. And then you create a log record once the data is on the silver layer. And this code on the GitHub of this class about this class changes and this class merge here, I have them on top of the notebook because usually you have a library, you install the library and you import apparently the classes and the functions you want, but here, just for the sake of this example, I've placed those functions at the top of each notebook. And then here again we have the widgets. So here you can select multiple, for example, not here, it's a drop down, you can select only one input table, one metric column, one prefix, and one silver table, which is the target table. Okay, so how can we run this, how can we fetch, for example, CPU percentage in one notebook and the memory utilization in the other notebook and disk utilization? How can we do that at the same time? I have another notebook. Again, I've gone to the same thing before, and we are using widgets again, but this time we can select multiple options, and let's, for example, select all those metrics. And what we are going to do here, so let's run this, and what we are going to do here, we have a notebook data class, then we are going to use thread pool executor. We parse the metrics here, the metric names and all these kind of things, and then let me uncomment that. And what we are going to do here we have this submit notebook function that runs using dbutils.notebook.run. We run the notebook that we want, passing the parameters that we want here, notebook.params, and we are using a thread pool executor to actually run the notebooks simultaneously, the extraction notebook simultaneously, and then the transformation notebooks simultaneously. So from the bronze layer, then to the silver layer, and then we have the whole data pipeline running simultaneously. We have 3 pipelines here, as you can see. We are running the KPI extract with those parameters, then those parameters, and then for memory percentage. And then once the extraction steps are done, then we are performing the transformation steps, which is moving the data from bronze to silver. And it's that simple to build a pipeline and gather data and fetch data from an app service plan and fetch all these metrics here. There are a lot more metrics. We just fetch the basic ones, but you can there are a lot of metrics, so you can play around with it. As you can see now, the extraction steps have finished and the next steps for the serial layer have just started. For the disk percentage, the CPU, and the memory, right? So, and we would be able to see the data on the bronze layer and the silver layer all together. Okay, the pipelines have already run, and then if we go into our Unity catalog, we would be able to see all the tables. We have the bronze CPU percentage with all those columns. Let it load. So we have the row ID, the date key, CPU timestamp, average score, and the metric. So the average score is 0 for this day. And then we have the silver CPU percentage. We can see the sample data here. Here we exclude the average scores that are null. That's why we have only the records with an average score which is greater than 0. Okay, so you got the point here, and how we can build a simple data pipeline without even using workflows. We can use only notebooks and Python scripts. The first is the extraction step here, and we merge the data on the bronze layer. We actually save the data on the bronze layer without performing any changes. We just add a timestamp column and a row ID and the date key, and then on the silver layer we perform, we cleanse the data, we perform null data quality checks and these kind of things. So this is how you can build a data pipeline using notebooks, and how you can extract and fetch the metrics from an app service plan. I think it's a good example to demonstrate how you can build a data pipeline. However, remember, this is a very simplistic approach. It's not very generic, it's not that complicated, it's not for production level. You just start building on top of this.
This is it for today, guys. I hope you enjoyed the video and you learned something new. I'm working on something very similar at work, and that's why I thought maybe it would be useful for someone else as well, and that's why I shared my knowledge based on what we have done on previous videos. Please click the like button, subscribe to the channel, leave a comment, and I will see you in the next one. Thank you.